Welcome to Video 8 of Sec 1 Geography, Water Management, Singapore's 4 National Taps. This video answers one of the most fascinating questions in the entire geography syllabus. Singapore receives about 2,400 millimeters of rainfall every year, roughly twice what London gets, and yet it is one of the most water-stressed countries on Earth. How? And more importantly, how did Singapore solve it? Let's find out. Let me start with the paradox. Singapore gets a lot of rain. 2,400 millimeters per year is more than double London's annual rainfall. It is more than New York, Sydney, and Tokyo combined. By any standard, that is a very wet place to live. And yet, by any global measure of water security, Singapore ranks as one of the most water-stressed countries in the world. Why? The problem is not how much it rains. The problem is that 5.5 million people live on just 734 square kilometers of land, with no major rivers, no natural lakes, and no underground aquifers to store water between rain events. Rain arrives fast. If you do not catch it immediately, it flows across the tarmac, down the drains, and into the sea. It is gone. And with no geological storage, there is nothing to buffer a dry period. This is the structural challenge that Singapore has had to engineer its way out of. Here is what we are covering today. Look at the roadmap on screen. Chapter 1 explains the structural mismatch, why rainfall alone is never going to be enough for Singapore. Chapter 2 covers Tap 1 and Tap 2, local catchment water including Marina Barrage and imported water from Malaysia. Chapter 3 goes deep into NEWater, the 3-stage production process, the 40% contribution, and how to write the 3-mark WAQ2 answer. Chapter 4 covers desalination, the NEWater versus desalination comparison, the diversification principle, and the 6-mark evaluate answer structure. 13 marks across 4 questions. Everything you need is in this video. Before we start the content, let me flag 4 mistakes that cost students marks on this topic. Mistake 1, naming only 2 or 3 taps in WAQ1. The question awards half a mark for each tap. Name all 4 to get both marks. Mistake 2, describing only one stage of any water production for a 3-mark question. 3 marks means 3 separate ideas. Production process, what it is used for, and why it matters for water security. One stage alone scores 1 mark out of 3. Mistake 3, writing. NEWater is clean, as its importance for water security. That tells you what it is. The marks want you to explain why it is important for Singapore's ability to supply water, which means weather independence, the 40% of total demand it meets, and the reduction of foreign dependency. Mistake 4 in the evaluate question, describing what each tap does without evaluating whether the strategy is effective. Description alone scores a maximum of 2 marks, regardless of how detailed it is. The marks are in the WHY. Here are the 4 exam questions this video addresses. WAQ1 is 2 marks, name all 4 taps. Half a mark each, all 4 needed for full marks. WAQ2 is 3 marks, explain how any water is produced and why it is important for water security. 3 separate ideas. WAQ3 is 2 marks, explain why Singapore cannot rely on a single water source. Specific vulnerability plus diversification response. The final exam practice question is 6 marks. Evaluate how effective the 4 national taps strategy is. Describe at least 2 taps, explain strengths and limitations, reach a final judgment. 13 marks in total. Let's go. Chapter 1. Why Singapore has a water challenge. Before we can appreciate what Singapore has built, we need to understand the problem it was solving. 4 structural reasons, not 1, explain why a very rainy city-state still struggles with water security. Look at the 4 problems on screen. Problem 1, small land area. Singapore is 734 square kilometers. Even if rain fell constantly, the total volume of water you can collect is limited by how small your land surface is. A small island is a small catchment. Problem 2, high population density. Over 7,500 people per square kilometer. The ratio of population to catchable rain is extreme. Per person, the available rainfall is tiny despite the 2,400 millimeter total. Problem 3, no large rivers, lakes, or aquifers. In most countries, groundwater acts as a buffer. It stores water underground across dry months and is drawn on when needed. Singapore has none of this geological storage. Rain arrives and must be captured immediately, or it flows to the sea. Between rain events, there is no reserve to draw on. Problem 4. No large upstream catchment from neighbors. Cities on major rivers, Cairo on the Nile, London on the Thames, can draw on water collected across vast inland catchments hundreds of kilometers away. Singapore cannot. It only has the water it catches on its own land. Let's put numbers to the problem. Look at the figures on screen. 734 square kilometers, one of the smallest countries on Earth. 5.5 million people, over 7,500 per square kilometer. Annual rainfall of 2,400 millimeters, heavy equatorial precipitation year-round. But 0 large aquifers, 0 major rivers. All 17 of Singapore's reservoirs are engineered, none is a natural lake. And then the number that ties everything together, 2061. That is the year the remaining bilateral water agreement with Malaysia expires. After 2061, Singapore must be fully water self-sufficient. That deadline is not abstract. It is the engineering target that drives the entire 4-TAP strategy. Singapore's response to all 4 structural problems is the 4 national taps. Look at the 4 taps on screen. Tap 1 is local catchment water, rainwater collected across Singapore's land surface and stored in reservoirs. Tap 2 is imported water piped from the Johor River in Malaysia. Tap 3 is NEWater, highly purified recycled wastewater. Tap 4 is desalinated water, fresh water extracted from seawater. Each tap is entirely independent. Each has a different source. Each has different strengths and different failure modes. Together, they form a system where no single failure can cause a total supply crisis. This principle is called supply diversification, and it is the foundation of Singapore's entire water strategy. Keep that term ready. It appears in the evaluate question. Chapter 2, Tap 1 and Tap 2. In this chapter, we look at how Singapore collects and imports its water, the most traditional of the 4 taps. We also look at why Tap 2 became a strategic vulnerability and how that vulnerability drove the development of NEWater and desalination. Tap 1 is local catchment water. The concept is simple: catch the rain before it escapes. Look at the diagram on screen. 2/3 of Singapore's total land area, about 67%, is gazetted as water catchment. That means the entire drainage network from those areas is designed to channel rainwater into reservoirs. Rain falls on a roof in Ong Mo Kio, flows into a drain, into a canal, into a river, into a river, into a river, works treatment plant, and eventually to your tap. Singapore has built 17 reservoirs to store this water. That is a remarkable density for a country of this size. The advantage, it uses Singapore's natural rainfall, the 2,400 millimeters, without the energy-intensive processing that NEWater and desalination require. The limitation, it is bounded by land area and vulnerable to drought. It cannot meet demand on its own. The most important specific example of Tap 1 is Marina Reservoir, which we look at now. Marina Barrage is one of the most innovative pieces of water infrastructure in the world. Look at the diagram on screen. Completed in 2008, Marina Barrage is a dam built across the Marina Channel, the narrow waterway connecting the inner harbor to the open sea. Before 2008, the inner harbor was tidal. Its water level rose and fell with the sea, and the water itself was salt water, unusable as a freshwater source. By damming the channel, pubs separated the inner waters from the sea. With the salt water shut out, rainwater falling on central Singapore, flowing through drains, roads, and canals, could accumulate in what became Marina Reservoir, Singapore's 15th reservoir and the only reservoir in the heart of a city anywhere in the world. The catchment area served by Marina Reservoir is approximately 10,000 hectares, 1/6 of Singapore's total land area. This is the largest urban catchment in Singapore. And then the second function, flood control. During heavy rain, if the reservoir fills too fast, large pumps beneath the barrage activate and push excess stormwater out to sea. This prevents the low-lying areas around the CBD and Chinatown from flooding. 2 functions, 1 structure, water supply, and flood protection built into the same dam. Tap 2 is imported water from Malaysia. Water is piped from the Johor River across the causeway into Singapore, where it is treated and distributed. Historically, this tap provided a significant share of Singapore's water supply at relatively low cost. But look at the two dates on screen. One water agreement with Malaysia expired in 2011. Singapore chose not to renew it, instead increasing its self-reliance through the other taps. The second and final agreement expires in 2061. The key limitation: geopolitical dependency. Singapore is relying on a foreign country to supply an essential resource. If Singapore-Malaysia relations deteriorate, if there is a political dispute, a renegotiation gone wrong, or a change in government priorities, that supply could be reduced or interrupted. A city-state of 5.5 million people cannot afford to have its water security dependent on a bilateral agreement that could, in principle, be cancelled or pressured. This is the lesson that Tap 2 taught Singapore. Relying on a single foreign country for a critical resource creates strategic vulnerability. Look at the causal chain on screen. If political relations deteriorate, the imported water supply could be reduced or stopped. A city-state cannot gamble its survival on a foreign agreement. This is the direct motivation behind Taps 3 and 4. NEWater requires no rainfall and no foreign country. Desalination uses the sea that Singapore already sits in the middle of. Both are entirely within Singapore's control. And notice the result: NEWater now meets about 40% of Singapore's total water demand. Desalination meets about 30%. That is 70% of total demand supplied from weather-independent, self-reliant sources. By 2061, the goal is for Singapore to be fully self-sufficient, and at 70% already, it is well on track. Chapter 3, Tap 3, NEWater. This chapter is the most exam-critical in the video. The 3-mark WAQ2 question is entirely about NEWater, its production process, its use, and its importance for Singapore's water security. Let's break it down into the 3 marks you need. What is NEWater? NEWater is highly purified recycled water. Its source is used water, the wastewater from Singapore's sewage system. What goes down the drain in homes, factories, and buildings is collected, treated through a 3-stage process, and turned into water that meets or exceeds WHO drinking water standards. Look at the 2 key facts on screen. There are 5 NEWater plants in Singapore. Together, they currently meet approximately 40% of Singapore's total water demand, making NEWater the single largest contributor to Singapore's water supply. Here is the logic that makes NEWater so valuable. As long as Singapore's population uses water, there is always input to treat. A drought that stops rainfall has zero effect on NEWater production. A political crisis with Malaysia has zero effect on NEWater production. Its reliability is tied to Singapore's population, not to the weather and not to any foreign country. Now the 3 production stages. These are the marks in WAQ 2.1. Learn the stage name and what it removes. Look at the process diagram on screen. Stage 1, microfiltration. Used water passes through fine filter membranes. These membranes are sized to remove bacteria, suspended particles, and larger contaminants. The water coming out of this stage is cleaner, but not yet safe. Stage 2, reverse osmosis. This is the critical stage. Water is forced at very high pressure through ultra-fine reverse osmosis membranes. The membranes are fine enough to block virus particles, dissolved salts, and chemical contaminants, while allowing water molecules to pass through. Reverse osmosis is what makes NEWater so pure. Stage 3, ultraviolet disinfection. The water is exposed to UV light, which kills any microorganisms that survive the first 2 stages. The result, water that meets or exceeds WHO drinking water standards. 3 stages: microfiltration, reverse osmosis, UV disinfection. Learn those 3 stage names for WAQ2. So where does NEWater actually go? Look at the 2 destinations on screen. The primary destination, the main use, is industry. Wafer fabrication plants, which manufacture semiconductor chips, require water that is actually purer than standard drinking water. NEWater is ideal for this. Cooling towers in commercial and industrial buildings are another major use. The secondary use is reservoir blending. During dry periods, NEWater is pumped into Singapore's reservoirs, where it mixes with rainwater. The blended water then goes through the standard treatment process again before reaching people's taps. This means most Singaporeans are already drinking water that has NEWater in it, indirectly. Why not directly from the NEWater plant to the tap? NEWater meets WHO drinking water standards. The issue is not safety, it is public perception. People's psychological reluctance to drink water labeled as recycled wastewater means the reservoir blending approach is a practical communication choice, not a technical necessity. Now the third part of WAQ2, why NEWater is important for water security. This is where most students lose a mark by writing NEWater is clean or NEWater is pure. Those describe what it is. The question asks why it is important for water security. Look at the 3 reasons on screen. I'll give you all 3. Pick the one that you can explain most clearly in an exam. Reason 1, weather independence. NEWater does not need rain to operate. It works through drought, through a dry spell, through any weather pattern. For a country that depends on rainfall for tap 1, having a 40% supply source that ignores the weather entirely is a major security gain. Reason 2, scale. NEWater meets approximately 40% of Singapore's total water demand. It is the largest single contributor to supply. Losing NEWater would require replacing 40% of all the water Singapore uses. No other single tap could absorb that gap. Reason 3, reduced foreign dependency. NEWater requires no agreement with any foreign country. It cannot be cut off by a political decision in Kuala Lumpur. It is fully within Singapore's control. Any one of these 3, clearly linked to water security, is the third mark in WAQ2. Your turn. Look at the practice pause on screen. WAQ2, explain how NEWater is produced and why it is important for Singapore's water security. 3 marks. Write 3 separate points. Point 1 covers the production process. Describe at least 2 of the 3 stages, and for each stage, name what it removes. Point 2 covers the primary use. Point 3 explains the importance for water security. Link it clearly to supply reliability, not just to water quality. When you are ready, unpause and I will walk you through the model answer. Welcome back. Let's go through the model answer for WAQ2. Look at the 3 points on screen. Point 1, production, 1 mark. NEWater is produced through 3 stages. Microfiltration removes bacteria and suspended particles, reverse osmosis forces, water through ultra-fine membranes to remove viruses and dissolve salts, and UV disinfection kills any remaining microorganisms. Stage name plus what it removes, that is, the format for each stage. You need at least 2 stages, 1 mark. Point 2, use, 1 mark. NEWater is supplied mainly to industries such as wafer fabrication plants and cooling towers, and is also topped up into reservoirs during dry periods to blend with rainwater before treatment. Named use, industry. Reservoir blending as the secondary use, 1 mark. Point 3, importance for water security, 1 mark. NEWater is important because it is weather independent. It does not rely on rainfall or foreign supply, and currently meets about 40% of Singapore's total water demand, making it the largest contributor to water security. Weather independence linked to security. 40% figure quoted. 1 mark. 3 points. 3 marks. Note the rule at the bottom, production plus use plus importance. 3 separate ideas. Do not repeat the same idea across points. Chapter 4, Desalination. The comparison table, the diversification principle, and the 6-mark evaluate structure. This chapter covers the 4th tab, shows you how to compare NEWater and desalination, explains why Singapore needs 4 independent sources rather than 1, and gives you the scaffold for the evaluate question. Tab 4 is desalinated water. The source is seawater, the ocean surrounding Singapore. Look at the process diagram on screen. Seawater is pumped into the desalination plant and forced at high pressure through reverse osmosis membranes. These membranes remove the salt ions and dissolved substances while allowing water molecules to pass through. Two streams emerge. Fresh water goes to treatment and distribution. Concentrated brine, essentially very salty water, is returned to the sea. Singapore has multiple desalination plants, including the Tuas desalination plant. Together, they currently meet about 30% of Singapore's total water demand. The key advantage: the sea surrounding Singapore is effectively an unlimited source. It does not depend on rainfall. It does not depend on any foreign country. As long as Singapore has the energy to run the reverse osmosis process, it can produce fresh water. The key limitation: desalination is by far the most energy-intensive of the four taps. It requires sustained high pressure to force seawater through the membranes. It is also the most expensive per liter produced of any tap. And the brine output must be carefully managed. Releasing large volumes of very concentrated salt water near marine ecosystems can harm them. Now let's compare NEWater and desalination side by side. Look at the comparison table on screen. Both are weather independent, that is a shared strength. Both use reverse osmosis as their core process, that is a shared technology. Both reduce Singapore's reliance on Malaysian imports, that is a shared strategic benefit. But they differ in important ways. NEWater meets 40% of demand, more than desalination's 30%. NEWater's energy cost is high, but desalination's is very high, the most energy-intensive option. Financially, desalination is also the most expensive per liter. The environmental profile also differs. NEWater takes a waste product, used water, and turns it into a resource. Very little new water is extracted from the environment. Desalination extracts from the sea and produces brine waste that must be managed carefully. For the evaluate question, both the shared strengths and the unique limitations of each tap are relevant. Weather independence is a major strength of both. High energy cost and expense is a significant limitation of both, but more severe for desalination. Now the diversification principle, the concept that ties all four taps together. Look at the four-pillar diagram on screen. Each tap has a different vulnerability. Local catchment is vulnerable to drought and constrained by land area. Imported water is vulnerable to political risk and will expire in 2061. NEWater faces public perception challenges and has high energy costs. Desalination has the highest energy cost and is the most expensive. The insight is this: because each tap fails in a different way, having all four means that almost no single event can cause a total supply failure. A drought reduces local catchment, but has zero effect on NEWater and desalination. A political crisis with Malaysia cuts tap 2, but does not affect the other 3. An infrastructure failure at a single plant stops that plant, but 3 other independent systems continue running. This is supply diversification, no single point of failure. 4 independent systems, each with different vulnerabilities, together covering the full demand. That is what makes Singapore's water strategy a global model. Now let's look at the 6-mark evaluate structure. This is the scaffold for writing a full mark evaluate answer. Look at the 6 boxes on screen. Mark 1, describe at least 2 taps. Name them, state the source, and briefly explain how each works. Correct description of 2 taps earns the first mark. Marks 2 and 3 explain strengths. 2 separate strengths with geographical reasoning. Not just what the tap does. WHY, it makes the strategy effective. For example, diversification ensures no single failure causes a total supply crisis is a reason. NEWater meets 40% of demand and is weather independent is another. 2 strength ideas, 2 marks. Marks 4 and 5 explain limitations, 2 separate limitations with geographical reasoning. For example, NEWater and desalination are energy-intensive and expensive, limiting how quickly Singapore can scale these taps. Singapore remains dependent on Malaysian imports until 2061, 4 decades of residual geopolitical vulnerability. Mark 6, final judgment. Take a clear position. Overall, is the strategy effective? Why? Back it with specific evidence. Use the figures 40%, 30%, 2061. Description without evaluation, maximum 2 marks. The other 4 marks are entirely in the WHY. Your turn. Look at the practice pause on screen. The final exam question: evaluate how effective Singapore's 4 national taps strategy is in ensuring long-term water security. 6 marks. Use the scaffold, describe 2 taps, explain strengths, explain limitations, reach a final judgment. 3 key figures to use: NEWater meets 40% of demand, desalination meets 30%, the Malaysian agreement expires in 2061. Allow yourself 12 to 15 minutes. Write in continuous prose, not bullet points, that is, the exam format. Pause now. When you are ready, unpause and I will walk through the model answer. Welcome back. Let's go through the model answer together. Look at the 4 sections on screen. Mark 1. Describe 2 taps. Singapore's 4 national taps include local catchment water, which stores rainwater in 17 reservoirs, and NEWater, which is purified recycled wastewater produced through microfiltration, reverse osmosis, and UV disinfection. Named, described. 1 mark. Marks 2 and 3, strengths. The strategy is effective because diversification ensures no single failure causes a total supply crisis. NEWater is particularly important. It is weather independent and meets 40% of total demand, reducing reliance on both rainfall and foreign imports. Diversification as a strength, 1 mark. NEWater's weather independence and 40% figure, 2nd mark. Marks 4 and 5, limitations. However, NEWater and desalination are both energy-intensive and expensive, limiting how quickly Singapore can expand these taps. Singapore also remains dependent on Malaysian water imports until 2061, nearly 4 decades of residual geopolitical vulnerability. Energy cost limitation, 1 mark. 2061 foreign dependency, 2nd mark. 2061 foreign dependency, 2nd mark. Overall, the 4 national tap strategy is highly effective as a medium-term solution. Long-term sustainability depends on reducing the energy costs of NEWater and desalination, possibly through renewable energy, and completing the transition away from Malaysian imports before 2061. Clear position, specific reason, evidence used, 1 mark, 6 marks, 6 ideas, each explained with geographical reasoning. 4 mistakes, fixed before you sit the exam. Mistake 1, naming only 2 or 3 taps in WAQ1. The question awards half a mark each. Name all 4, local catchment water, imported water from Malaysia, NEWater, desalinated water. Mistake 2, describing only 1 stage of NEWater production for a 3-mark answer. 3 marks means 3 ideas. For the production mark, name at least 2 stages and what each removes. Microfiltration removes bacteria. Reverse osmosis removes viruses and dissolved salts. UV disinfection kills remaining microorganisms. Mistake 3, writing. NEWater is clean, as its importance for water security. That is what it is, not why it matters for supply. The importance mark requires you to explain why it strengthens Singapore's ability to maintain supply. Weather independence, 40% of demand, no foreign dependency. Pick 1 and explain it. Mistake 4, writing an evaluate answer that only describes what the taps do. Description without evaluation, without explaining. WHY. The strategy is effective or limited, scores a maximum of 2 out of 6 marks. The other 4 marks require you to explain the reasoning behind each strength and limitation and to reach a final judgment. 5 things to carry away. 1. 4 national taps, local catchment, imported water from Malaysia, NEWater, and desalinated water. Each tap has a different source, different strengths, and different vulnerabilities. 2. Marina Barrage, completed 2008, Singapore's 15th reservoir, 10,000-hectare urban catchment. 2 functions, water supply and flood control. 3. NEWater, used water treated through microfiltration, reverse osmosis, and UV disinfection. Primary use, industry. Scale, 40% of demand. Key strength, weather independent. 4. Desalination, Seawater through reverse osmosis to produce fresh water with brine as a byproduct. Scale, 30% of demand. Key strength, unlimited source. Key limitation, highest energy cost. 5. Evaluate structure, describe taps, explain strengths, explain limitations, reach a final judgment. Use figures, 40%, 30%, 2061. Description without evaluation scores at most 2 out of 6 marks. Now go and complete the worksheet, the WA practice, and the final exam practice. Check your WAQ2 answer against the 3-point structure: production, use, importance for water security. Subscribe for the next video, water pollution and water management.